All right, this video is designed to give you some help with 6.1. I definitely recommend reading this section, but this is just going to be some of the definitions and to help you out. So 6.1, we're going to be talking about critical values. Now, we already know that critical values are the x-coordinate of an extreme point. And that doesn't change. We just add some information to this and we find a new way to find critical values. So our new definition for critical values has three parts. First part, the x value that makes the derivative equal 0. This is the one that we're going to see the most. We're going to see this all year, and in fact, you're going to be working with this quite a bit next year when you take calculus. The second one that we're not going to see quite as often is when, when the derivative does not exist. This is going to happen to us in a couple chapters when we start dealing with radicals, but not so much right now. And then the third one that we aren't going to focus on all that much this year, the endpoints of a given domain. Now, what this new definition does is it doesn't guarantee that when we have a critical value, we have an extreme point, since this new definition doesn't always lead to an extreme point. It does a lot of the times, but not always. So let's take a look at an example. Let's say we had the function negative 5x squared minus 30x plus 51. And we want to find the critical values. Well, the first thing I'm going to do if I want to find critical values is I'm going to take my derivative. And then now, based on our new definition, I'll set my derivative equal to 0, solve, and I now know that x equals negative 3 is a critical value. With this information, I'm actually going to be able to do a lot of things. I can make a sign pattern of my derivative now. If I substitute into my derivative, something to the right of negative 3 like 0 would get me a negative value. On the right would get me a positive value. What this is going to tell me is that f increases from negative infinity until negative 3. Since the derivative is positive to the left of negative 3, we know that f increases. It also tells me that f decreases from negative 3 on to infinity, since the derivative is negative to the right of negative 3. Now, if you think logically about what this means f has a maximum at x equals negative 3 because the function increased until negative 3 and then decreased after negative 3, essentially the parabola we would have expected from having a negative a value. Now, I can now find my extreme value. I can find my maximum. Move this value over. By subbing in x equals negative 3 to f of x. So f of negative 3 equals negative 5 times negative 3 squared minus 30 times negative 3 plus 51. And that value is going to lead to 96. Now, if we had to find our range, we now have all the information we need to find our range. Since we know that this is a parabola that opens downward, or more importantly, an even function, it's going to either have an absolute maximum or an absolute minimum. In this case, we already knew we had a maximum, and it turns out to be our absolute maximum. So my range would be all the values starting at 96 and then going down forever. Let's take a look at one more. say I had the function 3/2 x to the 4th plus 4x cubed minus 9x squared plus 10. I'll start by finding critical values. So that means I need to find my derivative first. 6x cubed plus 12x squared minus 18x. I need to set my derivative equal to 0. While I do that, I'm going to begin my factoring process. I'll continue my factoring process. Oh, wait. I made a mistake in my factoring, pardon me. X plus 3 and x minus 1. So I now know I've got critical values at x equals 0 because of 6x, x equals negative 3 because of x plus 3, and x equals 1 because of x minus 1. I can use this to create a sign pattern of my derivative, negative 3, 0, and 1. I can test values in my derivative. Again, when we make a sign pattern of the derivative, we focus on the derivative, and I would end up with these signs. So I now would know where my derivative is positive, f increases from negative 3 to 0, again because the derivative is positive, and then increases again from 1 to infinity. F decreases from negative infinity to negative 3 in union with 0 to 1. And again, I know it's decreasing because my derivative is negative. And this lets me be able to say that I've got a minimum at x equals negative 3 and at x equals 1, because again, my derivative was negative then positive, which means my graph would have been going down then up. I have a maximum at x equals 0, since that's where my derivative changes from positive to negative. If I wanted to find these values, I would substitute them in to the original. When I substitute in 1, I would get 6.5. If I substitute in 0, I would get 10. If I substitute in negative 3, I get negative 57.5. And now this will allow me to determine what my range is. Since this is a 4th degree polynomial, I know that it ends on either side by going up, which means I've got to have an absolute minimum. Well, if I look at the 3 values I came up with, I can see what my absolute minimum is. And so my range would be, pardon me, with a bracket, starting at negative 57.5 and going on to infinity. I realize I've made a mistake in the other one. So we're going to go back and correct that. In this other value, I would have been going down towards negative infinity, so pardon me, let me make my correction. My range would be negative infinity until 96. All right, this should give you a good idea of what you need to do in your homework. Again, take a look at the section, and we're going to talk all about this. Section 6.2 actually goes back and looks at all of this information all over again, so we'll take a look at that.